Right, so our last section for this week, okay, still unit circle trig, just part 3. A few different things we're going to look at. Okay, first thing we're going to look at is not just finding the trig functions of 30, 45, and 60, but any multiple of 30, 45, and 60. Okay, so multiples of 45 are numbers like 45, 45 times 2, 90, we already did that one. 45 times 3, 135, 180, 225, 270, and 315. Those are all your multiples of 45. Okay. Multiples of 30, those are numbers like 30, 60, 90, 120, 150, 180. Okay. Some of those I've just named we've already done. Okay. But the ones we haven't done we'll do. So we're still going to use the 30, 60, 90, and 45, 45, 90 right triangles. Exact same triangles as yesterday. So same numbers are going to be involved, just different quadrants. What was the length of the sides in the 45, 45, 90? They were the same. Yep, both square root 2 over 2. So for the 45, 45, 90, you need that number. What about in the 30, 60, 90? How long is the short side? A half, and the long side? Square root of 3 over 2. Okay, that's all we need. So we'll just start with some examples. Okay, we're going to find the 6 trig functions of 135. Just by looking at your angle, you should be able to tell if this is going to be 45, 45, 90, or this is going to be the 30, 60, 90. Okay, look at 135. Is that a multiple of 30, or is it a multiple of 45? Yeah, it's 45 times 3. Okay, so we're going to sketch that angle, and then we'll make our triangle, and the triangle is going to be the 45, 45, 90. Okay, so here's 180. This would be 90. Where's 135 in relationship to 90 and 180?
What is it, 135?
Yep, 135.
What is that? Quarter of the way?
You think it's closer to 90, closer to 180, or you think it's right in the middle?
It's right in the middle.
It is. It's right in the middle.
Oh.
Right? 135 is 45 degrees past 90, but it's still 45 degrees away from 180. Okay, so you're going to make your triangle. Always draw your hypotenuse to the origin. And draw the side perpendicular to the x-axis. Okay, earlier somebody said both sides are root 2 over 2. So I'm just going to label those. Any question why I'm not using the 1/2 and root 3 over 2? Okay. Both of these, it's hard for me to fit it in, but that's a 45. And that's a 45. Okay. I know that because if you take 90 and you add 45, okay, it brings me to 135. Right, so now when you write the coordinate for 135, just make sure you take into account the direction you went. Okay, we went left and then up. Okay, so thinking about my x value, is that going to be positive or negative? Negative. So negative on the x. How about the y? Positive or negative? Positive, because we went up. Okay. Points in quadrant 2 always have a negative x, positive y. Okay, and now from here, it's just like what we've done before. Just make sure you don't lose track of that negative. Okay. All right, let's start with our sine. Natalie, what is my sine?
Positive root 2 over 2.
Yep. So you pick the positive one, and that's correct. Sine is y. 2 over 2. Okay, John, what about my cosine?
Negative root 2.
Yep, it's the x value, which is negative root 2 over 2. And now tangent, just imagine putting a line in here and divide these two things. Okay, Amy, what would you get if you divide root 2 over 2 by negative root 2 over 2. Yep, negative 1. Okay, any question on the first three? All right, so Taylor, once I get the 3 on the left, what am I going to do with each one of them to get the 3 on the right? Yeah, we're going to flip each one. Okay, so Carter, what do I get when I flip this first one?
Root 2, I mean 2 over root 2, but you have to fix that.
Yep, you're going to get 2 over root 2, and when you fix it, okay, I know we've gone through that one a couple times now, you just get root 2. Okay, does anyone need me to go through that again, how you fix it? Okay, and on the test, you can just write that. You don't have to show me. If you fix it in your head, that's fine. How about secant? Yeah, it's the same as the sine, and sine and cosine are the same except for the sine. So secant and cosecant are the same except for the sine. Negative root 2. And lastly, what do you get if you flip negative 1? Negative 1. Question on that one? Mm-hmm.
Did you do the tangent one more time?
The tangent?
Yeah.
So the tangent, basically just imagine dividing sine by cosine. Okay, divide y by x. Since we're dividing two things that are the same, except one of them's negative, the answer is negative 1. Okay, it's kind of like dividing two things that are the same, except make one of them negative. Okay, negative 1. Okay, any questions on that one? Okay, I think that's going to be the only one today where we go through all 6. Okay, the rest of them are going to be set up like the test, where I just ask for one of the 6. All right, so cosecant of pi over 4. Hey, Emily, what would you do first here? Yeah, we could make pi over 4 degrees. Okay, and Austin, if I change that to degrees, what's pi over 4?
45 degrees.
45 degrees. So this actually is going back to what we did yesterday. Okay, without drawing the triangle, does anybody remember the coordinates for 45? Square root of 2 over 2. Square root of 2 over 2. Okay, if you didn't remember and you need to sketch it, mark your 45 degree, make your triangle. Bless you. Okay, label your angles. And then you have to memorize that in the 45, 45, 90. Each side is root 2 over 2. This time positive, positive. Because we're in quadrant 1. Okay, so they're asking for cosecant. Bailey, what trig function do I flip to get cosecant? Flip the sine. And sine is which letter?
The y.
Sine is the y. So take the y and flip it. I'm going to get 2 over root 2. And can you tell me what that would simplify to?
Root 2.
Just root 2. And that's it. You don't have to find the other 6. Okay, so on the test, 2 things I'm going to look for. Did you give me the right coordinate? And did you give me the right answer? Okay, question on that. Okay, try sine 225. Okay, first thing I like to do is just get an idea of what quadrant I'm going to be in. So, Cade, what quadrant am I going to be in here?
Third one all the way around. Bottom left.
Yep. I'm going to be in the bottom left. Okay, now we have to figure out, are we closer to 180? Closer to 270? Right in the middle. Right in the middle. Okay, there's 225. Okay, so draw your hypotenuse to the origin. always draw the other side perpendicular to the x-axis. And now, Ashley, if you look at that, how many degrees is it from 180 to 225? What would you add to 180 to get 225? How much? Close, not 35, Emily.
45.
You'd add 45. Okay? So what you add tells us what kind of triangle it is. This is a 45-degree angle right there. And because they all have to add up to 180, so is the other angle. Okay, Jason, how long is each side in the 45, 45, 90? Yep. So I'm going to label each side. But be careful when you write the coordinate. Take into account the direction. So Wes, what's my coordinate to get to 225?
It's going to be, for your top one, it's going to be negative square root 2 over 2.
Yep. So negative on the x,
Yep.
and
And the bottom one, that's also going to be negative.
that's also negative because we went down. That's it. Right. So that's good. So that's the first half. We got our coordinate. And then Kylie, they want the sign. So sign is which letter?
Y.
Yep. Sign is the y, and that's it. Any questions on that one? Right. So we've done a 45-degree angle in quadrants 1, 2, 3. Okay, the last one, the only other one you can do is in quadrant 4. Right, so I kind of gave you a hint at where this angle is going to be. It's a 45-degree angle in quadrant 4. Without even doing the arithmetic, does anybody know what the 45-degree angle in quadrant 4 is?
315.
It's 315. Okay? If you didn't recognize it, just take your calculator, do 7 times 180, divide by 4. Okay? So that's the cosine of 315. Okay, how do I know it's the 45, 45, 90? That number is a multiple of 45. It's not a multiple of 30. Okay. All right, so I'm going to draw my triangle. Okay, each angle is a 45. And now we've just taken that triangle and flipped it into quadrant 4. Okay, each side is the same length, root 2 over 2, root 2 over 2. But when we write the coordinate, we just got to be careful with negatives. So, Melissa, can you tell me what my coordinate for 315 is going to be?
Root 2 over 2 and negative root 2 over 2.
Right, positive root 2 over 2, negative root 2 over 2. Okay, now they're looking for cosine. Cody, what's my cosine? Yep, cosine is the x value, which in this case is square root 2 over 2. Okay, so now we've done a 45-degree angle in every quadrant. Okay, keep in mind on the test, I could ask you for any one of the 6. I could say, what's the sine of 315? What's the tangent? What's the secant? Right, but as long as you know how to find this coordinate, you can find any trig function I ask for. Okay, questions on that one? All right, let's look at this one. Tangent of 120. Okay, just looking at that angle, what kind of triangle do you think this is going to involve? Yep.
30 over 60.
Yeah, this is going to have to do with the 30s and 60s. 120 is not a multiple of 45. Okay? Okay?
How do you determine which one is?
Right, we got to figure out, is it the 1/2 root 3 over 2 or root 3 over 2 1/2? For that, I'm going to make a sketch. It's not quite what I wanted. Right, so we'll label our axes. And now I want to figure out where 120 is. Closer to 90? Closer to 180? Or right in the middle? This time it's closer to 90. Okay, and if you draw this correctly, you're going to be able to see which side is the short side and which side is the long side. Draw your hypotenuse. And draw your other leg. Okay, which side is the short side here, the base or the height? Yeah, the base is the short side. Okay. How long is the short side? 1/2. And how about the long side? Square root of 3 over 2. Okay, even if you didn't draw it perfectly to scale, another way you can tell, how far away from 120 is 90? Right, it's 30 degrees inside here, from here to here. So if this part is 30, how big is this part inside? That's your 60. Because together, this quadrant, that's a 90. So if this part's 30, this part on the inside is 60, and then all the angles have to add up to 180. So that's your 30. Smallest angle, always across from smallest side. Just like that. Okay, write our coordinate. Stephen, what's my coordinate for 120?
1/2 and then square root of 3.
Okay, I like both the numbers. Just be careful because we're in quadrant 2. What do we have to make sure of?
The negative
The negative number on the 1/2.
negative 1/2.
Yeah. Okay, so we're going to go left and then up. Okay, good. So there's your coordinate for 120. Last step, take y and divide by x. The 2's cancel. And what's going to be my final answer? Negative root 3. Okay, any question on that? Yeah.
Are you able to use 60 degrees to solve this too?
You mean if we had like the triangle more like that instead?
Right.
Yep, you can have that too.
Because 60 degrees is a multiple of 120 also.
Yep. If we had the triangle laying down, what would happen is the x and the y would switch.
Okay.
That triangle that I just drew, that would be for a 150. Okay. Now my 30-degree angle would be at the bottom, and my 60 would be at the top. Okay. Any question on that? So there's really 3 triangles you can draw in each quadrant. You can draw the 30, 60, 90 standing up. You can draw it laying down, and then you can also draw
45 right there.
the 45 right there. Okay, so there's 3 angles per quadrant. So 3, 6, 9, 12, and then 1 on each axis. 13, 14, 15, 16. So there's 16 angles I can ask you about. And that's it. Only those 16. Okay, and in a little bit, I'll show you a diagram that has all the triangles drawn in. I think it starts to look a little confusing if you do it by hand, but I'll show you the diagram. All right, let's look at this one just because we haven't done one like this today. Secant 690. Sydney, what would be my first step there? Yeah, just take 690, subtract 360, that's 330. 330 is a multiple of what number? 30. Okay, so when you sketch this, it's going to be the 30, 60, 90. So you should be thinking in your head numbers like 1/2 root 3 over 2. All right. There's 360, if you go all the way around. There's 330. Just a little bit before 360. Okay, make a triangle. And this time, which side is the short side? My base or my height? Yeah, the height. Okay, short side, we'll just squeeze it in here. Short side is 1/2. Long side, root 3 over 2. And my coordinate is going to be positive root 3 over 2, down 1/2. Any questions on how you'd continue from here to find secant? Secant is the cosine flipped. It's the x value flipped. Okay, so any questions on how to finish that up? Right. Anyone want to see one with a negative angle? Okay, a negative? Well, first thing I would do is change it to degrees, and then we'll cancel out the negative in a second. Okay, so 7 times 180 over 6, that should be negative, 210. And now, what am I going to add to that to make it positive? Yep, just add 360. So that's a 150. That's the angle Wes asked me about earlier, 150. So the 150 and the 120, they're very similar. The only difference is the x and the y switch places. There's 150. There's your triangle. Okay, so without me even labeling it, can somebody tell me what my coordinate for 150 is?
Negative root 3 over 2.
Yep, negative root 3 over 2, because the long side is root 3 over 2, and we went left. Okay, and 1/2, that's the short side, and we went up. Okay, cosecant, that one's quick. That's the sine flipped. Sine is my y. So what's the cosecant here? 2. Okay, any questions on that? Right, so I think that covers pretty well the unit circle with all the different angles you could have. All right, so this diagram looks a little confusing, but it's really the same triangles, just mirror imaged in every quadrant. Okay? There's 3 basic coordinates. Okay? The green triangles are all your root 3 over 2 1/2s. Your red ones are all the root 2 over 2s. And the blue ones are all the 1/2 root 3 over 2s. The only difference between these coordinates, are they both positive? Do you have both negative? Or do you have one negative, one positive? One positive, one negative. Okay? But all you need to know are these 3 numbers right there. And then put negatives in if you mirror it into other quadrants. Yep.
Are we allowed to make it
Not for this one. No.
Did you make that, Mr. Hager?
What's that?
Did you make that?
No, I think I found that online.
Oh.
Yeah. I had done one by hand. It didn't come out as good. And don't forget about the simple coordinates, like 1, 0, 0, negative 1, negative 1, 0, and 0, 1. All right, so if you know the quadrantal ones, those are easy to remember. And these 3, that covers everything on the circle. All right, so every every problem we've done up till now, the circle we've done it on has always been a unit circle. Right? So imagine, actually, imagine that triangle in red. Okay? That's our unit triangle. This side is 1, that side's x, that side's y. Well, let's imagine just, instead of stopping at the unit circle, okay, we keep going and we're going to find a point, not on the unit circle, but on a bigger circle. Okay? Still on that same ray, but now it's further out. Okay? It's not on a unit circle. Okay? I'm going to do the same thing we've always done. I'm just going to make a triangle. Right there. Now, there's a relationship between the green triangle and the red triangle. Does anyone know what they're called? They're not congruent, because they'd have to be exactly the same size. But they are similar. Basically, one is a bigger version of the other. Okay, so all we're really doing here is looking at a point on a bigger version of the triangle. Okay, so just move this over here. So let's call that R. This time we don't know the radius. Some distance from here to here. Okay, so I'm going to make a chart of the original. Okay, that's in the red triangle. That's what we've been doing. And then the new one, that's going to be the green triangle. Okay, so what's the radius of our red triangle? The original one. 1. Now, this one, the radius of the green triangle is R. Okay. Now, if we can somehow make this green triangle, we're going to try to make it back like the original problem. Okay. We don't want to deal with a triangle of radius R. I want to make it back so that it's a 1 again. And then we can do what we're used to. So if I had a triangle like this, and the radius was 5, okay? What would I have to do to that triangle to make it a radius of 1? How much smaller would I have to make it? I'd have to make it 5 times smaller. Okay? What if I had a triangle and the radius was 10? How many times smaller would I have to make it? I'd have to make it 10 times smaller. What if I had a triangle with a radius of R? I'd have to make it R times smaller. In other words, I'd have to divide it by R. Okay? If you divide by R, it makes it R times smaller. Okay? So what we're going to do is take R, and we're going to divide by R. Okay? That's going to turn that back into a 1. But okay, we have to also do it here and here. Because remember, if you make a triangle smaller, you have to make every side smaller the same amount. So if you're going to make the hypotenuse R times smaller, you have to make X R times smaller, and you have to make Y R times smaller. You're going to make everything R times smaller. So what's going to happen is X is now going to become R times smaller. Y is also going to become R times smaller. Okay, so it's like we're taking this green triangle and we're scaling it down. We're making it smaller. So the hypotenuse, we're forcing it to be 1. And that's the only change when you're on a circle that doesn't have a radius of 1. Every formula that I gave you before that was x, change it to x over r. Every formula that had a y, just change the y to y over r. Okay. Okay, so on the unit circle, what was sine equal to? Which letter? Y. What did I just say y becomes? Y over r. Okay. What was cosine on the unit circle? x. And what did I just say x is going to become? X over r. Okay, what was the last one? What was tangent? Tangent was y over x. Okay, well, I just said y becomes y over r. X becomes x over r. When you divide those two fractions to simplify it, what cancels out? The r's. Whenever you have the same denominator, we've seen that with numbers. Well, it works with letters too. So what happens is tangent actually stays the same. There's no change. Y over x. Okay, and just like we've done before, okay, if you've got the sine and you want the cosecant, flip it. R over y. If you have the cosine and you want the secant, take the cosine and flip it. R over x. And lastly, if you've got the tangent, flip it and get the cotangent. And again, r, that's the radius of the circle. Okay, what would happen to this formula if you changed r to 1? What would you get? You'd get sine equals what? You'd get y. That's what we had very first thing I gave you. Okay. What about in cosine? If you change r to 1, cosine would just be x. So the formulas that I gave you guys on Monday were really these formulas, except I always let r equal 1, okay? Because 1 was an easy number to start with. Now we can let r be any number we want. Okay? If it's 1, it just becomes y, x, 1 over y, and 1 over x, the original formulas. If r is not 1, just fill in whatever r is and do out the arithmetic just like we've done before. Okay. Does everyone have those formulas? All right. All right, so we're going to find the sine, the cosine, and the tangent. And I'm giving you the coordinate. The coordinate is 5, 12. So that's x. That's y. But what's the one other letter that appears in these formulas now besides x and y? R. Okay, we have to find r. Okay, and you already know how to find r. Okay, let me sketch the picture. Okay, just roughly sketch it. Okay, go right 5, up 12. Okay, it doesn't have to be to scale. Okay, make a triangle out of that point. How far to the right did I go? So the bottom side is 5. And how high up? 12. And now to find the radius of that circle, I'm really finding the what of that triangle. I'm finding the hypotenuse. Okay? If I can find the hypotenuse, then I know the radius of the circle, and then I just fill into my formula. How can I get the hypotenuse of this triangle? Yeah, use the Pythagorean theorem. So 5 squared plus what? 12 squared equals, just call it r squared. 5 squared is 25. Okay, 12 squared, 144. What's 25 plus 144? 169. And I picked 5 and 12, so we would get a nice answer. What's the square root of 169? 13. So now I've got r, x, and y. Just fill into those formulas. All right, so my sine is y over r. Okay, so what's my sine? Yeah. y divided by r. Y is 12. R is 13. And you're not going to have any square roots in this one. Okay, how about my cosine? Yep. X over r. Or 5 over 13. And what about my tangent? 12 over 5. Okay, so the only step, if you have to do a problem with a point that's not on the unit circle, use the point and the Pythagorean theorem to find the radius. That's the only extra step. Okay, most problems on the test are not going to be this type because we did a lot with radius 1. But there might be 1 or 2 examples where this is, you have this type. Okay, any questions on that? And what would you do with each of these to find the next 3, if they asked? Flip them. So 13 twelfths, 13 fifths, 5 twelfths.
You want to round that 13 12.
Do I want you to round it?
Oh, like make it like
No.
1.
No, you could just leave it as an improper fraction. Yeah. Don't worry about decimals, don't worry about improper fractions.
And it needs to be simplified, that you should do that.
Yes, if we ended up with a square root in the bottom, just like we've always done, simplify. Yep. All right, so if you're working with angles that are not multiples of 30 or 45, okay, you have to use the calculator. Okay, unit circle trig only works for angles that are multiples of 30 and 45. All right, so for this part, the most important thing is making sure you know how to put your calculator in the right mode. And make sure you know what the mode is just by looking at the question. Okay, in example 8, what mode should I put my calculator in?
Degree mode,
Yeah, degree. And how do I know?
because there's a degree.
Yeah, because there's a degree. If I take away that degree sign, it's a totally different question. Okay. Right, so on the graphing calculator, if you have one like that, you press mode. Okay. And then there's 2 choices, radian and degree. You pick degree. Okay. If you have a calculator, the one that says the TI-30, there's a button at the top that says DRG. Okay, you press that. And then choice 1 is degrees, you use the arrow. Choice 2 is radians. Okay, if you can't figure it out on yours, you can just use one of mine, or we can try to figure it out on yours at the end of class. All right, so I gotta change my mode. Okay, and then you just press sine 18. That's it. 0.309. Okay, so when you try that out, yours, make sure you get 0.309. Okay, next one says cosine 356 degrees. Do I need to change my mode? No, it's the same mode as the last problem. So I'll type that in. Okay, and somebody who tried that, what do you get when you do cosine 356? 0.998. Yeah, just make sure we round properly.
You might get wrong if you don't round it.
If you don't round it, well, if it's a multiple choice question and they had like 0.997 and 0.998, if they were really tricky with that, 0.997 is not correct. Yeah.
Does it have to be multiple choice?
There will be some multiple choice. Yep. But the ones where I ask you for the coordinate, that's not. You have to just write the coordinate yourself. Well, should I be in degrees for this one? No. This one I should be in radians. Okay, we get negative 0.916. Right, now, if this was multiple choice, let's say I had these as choices. Negative 0.916, 2.4, and let me do one more. 0.042. Which choice is correct? Yeah, for this problem, A is the correct choice. Which one is the correct choice now?
C.
C. That's the one I just did real quick on the calculator. Okay. Tangent of 2.4 in degrees. Okay, so now the correct choice is C. So there might be problems where you see both of these listed, but if you're in the wrong mode, you'll get the wrong answer. Okay. So that's correct. Okay, cosecant of 247. Well, first thing, I got to change my mode back to degrees. And now, do I have a button on the calculator that says CSC? No.
Does that cost negative one thing?
So that's a good guess. You might think that one of these cosine -1 things would do it. That's actually called inverse trig. That's something we're going to look at next week. So it's not those -1 things. But I could say it's a good guess. Yeah. Use sine and do what? And flip it. Okay. To find the cosecant, find the sine, and flip it. Okay, just like we've been doing all along. Okay, so you can either type it in this way, or if you can't do it as a fraction, you can just type sine 247, get the answer, and then do 1 divided by, and now type in that answer. Okay, on my calculator, I have a button I can just press answer, and it'll just type that in for me. If you don't have that, just type it in. Negative 1.086. Okay, these are the ones that where I see mistakes on the test. Most people make mistakes with the cosecant, the secant, and the cotangent. Okay, how about secant of 6? How would I type that one in?
That'd be in radians.
Yep, first thing I got to do is switch back to radians. Okay, so now I'm in radians.
That's COS and then 6.
Yep, so find the cosine of 6. And then what?
You have to put the in parentheses like you did that, or did it? Like,
On this one, because there was nothing after the parenthesis, it wouldn't matter.
oh, it doesn't matter. Oh.
Yeah. And then what's my last step? Yeah, flip it. Okay, I have a button, I can just press that and it'll flip it. You can type it in just like I did the last one.
How'd you get the -1 for
I have a button on here that does it for me. Okay. Yep. If you have a graphing calculator, it's the button right below math on the left side. It says x to the -1. Okay? Yep, some of those calculators do as well. They have the same button. If you don't have it, just type 1 divided by, and then type in 0.96017. Okay. Did anybody else get 1.041? Who got that? Okay. And if I was going to ask you to do cotangent, which function would you have to use and then flip? Tangent. Okay. Right, so any questions on that? Right, so now we've covered unit circle trig in the other 3 quadrants. We did it unit circle trig on a non-unit circle, okay, on a circle with a radius bigger than 1. And lastly, we looked at how to use the calculator. Okay, so that covers everything that's on the test. Tomorrow will be a review day. I'm going to let you work in groups. And I'm going to give you the last 15 minutes to start the homework. Okay, so homework's on 116, 49 to 57 odd, 67 to 81, this is all calculator. Okay, you need a calculator for every one of those. That's all. And then 83 and 84.